As the electron in this problem moves from point A to point B, the force on it is the magnetic force. It's charge Q times V cross B. Part A asks us to find the magnitude and the direction of the magnetic field. Let's find the direction first. Because the electron is moving in a circle, we know the net force on it must be towards the center of the circle, so that this vector F is directed in. Because the electron's charge is negative, the remaining term V cross B must be in the outward direction. Now the force F must be perpendicular to both the velocity V and the magnetic field B. Because the force and the velocity are in the plane of the screen, the magnetic field must be perpendicular to it. The right-hand rule shows us that V cross B is outward when the magnetic field is into the screen or into the page. I'll draw it in green like this. So we know that the magnetic field is into the page or into the screen, and now we can find the magnitude of it. Newton's second law tells us the net force acting on the electron is its mass times its acceleration. If we look at forces in the inward direction, we have the magnitude of the magnetic force, where theta is the angle between velocity and magnetic field vectors. That's 90 degrees, so sine of theta equals 1. And that equals mass times acceleration. The acceleration is the centripetal acceleration, v squared over r. So we can solve for B, the magnitude of the magnetic field. Substitute all the values, the mass of an electron, its speed, the magnitude of its charge, and the circle's radius, finding that the magnetic field has a magnitude of 1.60 times 10 to the minus 4 Tesla. Part B asks us for the time required for the electron to move from point A to point B. The electron's speed is constant, so we can equate it to the distance traveled, halfway around a circle, divided by the time it takes, t. Solve this for the time, and substitute all the values we were given, finding that it takes the electron 1.11 times 10 to the minus 7 seconds to make its way around the semicircle.